And this is also something that you will find in your paper. Let me see, what do they say? Paper 2, I think. Just make sure. Yeah, paper 2. Okay, this is the one place where you can score marks quickly and easily. Okay, you will need to study this for this year and you will repeat it next year. So if you know it now, it will go smooth next year. Okay, so this thing that we are drawing is called a cam, and this is something that helps other parts to move up and down or in a certain motion. So loci is like a head theme, and then the branch is a cam. Next year we'll do mechanisms, which is another branch, and then there was another branch called a helix, but we're not doing that anymore. So one of the branches, cams, have you heard of this before? A cam, what does it do? Do you know? Say again? It's a part in cars. Do you know what it does in a car? It moves it? Yeah. It rotates. Okay, so let me quickly show you what a cam looks like. I don't know if it's going to show, but a cam is almost this pear-shaped thing that rotates and moves the pistons in a car up and down. So, this thing, it helps to combust pressure in a car, and then you will have a spark plug that ignites and sort of explodes your fuel inside of it to then make your car move. Okay, but we are drawing this thing that's rotating. I don't know why it's so blurry. Okay, so every shape will have a different movement. Now, we will need to know what type of follower we have. In this case, it's a roller follower. And over here, we have a wedged shaped follower. The process stays the same. It's just a small detail that changes on how you get there. Okay, but we'll go through all of them. You will get a client that tells you, okay, I need this thing of mine to move in this certain motion. Then okay, client tells you, my bird ornament that I have in my garden needs to move in this motion to scare away other pests, and he will give you this graph, or you'll need to calculate it. So in our case, our client gave us the graph. We need to design the cam. Okay, so I'm going to start by your instructions. And this is easy. Don't overthink it. You'll see it will go quick. If you want to make notes, you're more than welcome to make notes on the page. Given information is the detail of a wedged-shaped follower, so this thing, wedged-shaped follower, for a disc cam in its starting position. So this will be 0.0. This is starting. so blurry. I'm sorry. But okay. Then you have the camshaft. So that is, let me see if I can find the picture again. That is sort of the rod that the cam sits on. It's the center. It's this thing. It stays put. Nothing moves regarding that. Then you have the minimum distance from the camshaft center to the cam profile. So there where the arrow touches, that's my cam profile. At a later stage, we'll give you nothing, and we will just explain. Then you'll need to redraw it. You will get an example of what it needs to look like, but you'll need to redraw. So that's why I'm showing as I'm going. Then you have the displacement diagram. That is this graph thing, displacement diagram. Then you have the direction of rotation. In this case, it goes clockwise. Now, the one trick that we have to this drawing is that if it goes clockwise, you number anti-clockwise. If the arrow points anti-clockwise, you number clockwise. That's the only trick to this questions. But it will always be like that. Then motion. The disc cam rotates at a constant velocity, imparting a uniform motion to the wedge-shaped follower as shown on the displacement diagram. So it's big words to say it moves like this. Okay, instructions. Project and draw the cam profile from the given displacement graph and insert all labels for the displacement graph. The horizontal scale for the displacement graph is 30 degrees is equal to 6 millimeters. Insert all labels for the cam profile, hatch the camshaft, show all necessary constructions. Okay, so let's start by labeling. Your labels will usually be the same, and you do get marks for your labels. So I'm starting at the top by labeling a displacement diagram. It's in the instructions if you want the spelling, because I don't know why it's so blurry. Displacement diagram. On the side, we're going to say displacement in millimeters. Displacement in millimeters. We need to number each one of these lines. We're going to start by 0 and end by 360. We're going to count in 30s. So it's 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. So these numbers that we have are degrees, and the label that we give here is rotation in degrees. Rotation in degrees. Underneath this label, you're going to write your scale, and then it says in your instructions that the displacement graph is 30 degrees equals to 6 millimeters. So our scale is 30 degrees equals to 6 millimeters. So in all the questions that you have in the future, the label stays exactly the same. The only thing that changes is the scale. Okay. Then, this is for the displacement diagram. Labeling is complete. I need to label this as my cam profile. Then, because I've labeled all of the lines on the graph, I need to label these lines as well. We know that the follower goes in a clockwise direction, so I need to number anti-clockwise. So 0 is here at the top, then it's 30, 60, 90, So looking at the instructions, I have inserted all the labels of the displacement graph, and I've also added the horizontal scale. Then insert labels for the cam profile, hatch the camshaft. Okay. So this circle that you have here in the middle, this is your camshaft, and I'm just going to hatch it. You can also take out your compass. So when we are going to draw our cam profile, my sharp point of my compass is going to be in the center the whole time. And I'm going to, for now, move degree to degree so that you can see how it works. But at a later stage, I'll project all of my lines and then complete the profile all at once. I'm going to start with 0 and 30. So 0 is located at the starting point. 30 degrees, if I take my ruler and I line it up with where the line and the graph cross, I'm going to project that to my center of the follower. So that's the height that 30 needs to reach when it gets to that degree. So I'm going to put my sharp point in the middle and open up to that 30 mark. I'm going to draw a curve until it touches 30 degrees. Okay, so this is then the point for 30. I'm going to do the same for 60. Take my ruler up to where line 60 meets the graph. Project it to the center line. Sharp point in the middle. Open up to 60. I draw a curve until it meets line 60. Making this my next point. Okay, so I'm just going to repeat this. When all of them has been plotted, all of the points are plotted, I'm just going to connect them freehand and then I'm done. Okay. Easy. Okay, so I'm going to continue with 90, where it crosses, I'm projecting it to the center line. From there, I put my sharp point in the middle, open up to line 90. I draw a curve until it touches 90, and that's my next point. Is everyone okay so far? Gonna continue 120. And 150. Continue next time. Okay, so process is just going to continue. Going to project each line to the center line. So after a while, if you get comfortable, you can just project it all and then make marks so that you don't have to jump between your compass and your ruler. And in a case where you feel like going around to the left side is too much, you're more than welcome to go around the right as long as the point lands on the same spot. You don't have to. You can just make a mark. So for example, I measure up to where 210 will be, and then I just make a mark on 210. So the next one for 270, it's on the highest point. So I'm just going to make a mark here on the edge. Then I'm moving down to 300. And if you have so many lines that it's getting difficult to see where you are working, I like to just make a mark. Then I don't have so many lines. Then you can open up to that mark that you've made. That will be your next point. Okay, last thing to do is to connect the dots, dark, and then you're done. Try to keep it one solid line and to have all of your corners very rounded. Because if it's something that's going to glide or turn and you have a sharp corner, then it's going to get stuck there. So the reason for labeling anti-clockwise, if it says clockwise, is because as this thing turns, let's say this thing moves and not the follower, so this thing turns, then turning clockwise would mean 30 would meet it first, then 60. So it's actually in the correct order. It just it looks like it's backwards because of how it will turn.